So here's an alternative approach to this problem that doesn't use clearing denominators. And so it forces you to wrestle with fraction arithmetic a little bit longer, but if you prefer it, we can just attack this problem straight ahead using SADMEP, right? Deal with subtraction and addition first, division and multiplication second, exponents, and then if there are parentheses, work toward the outside in. So you're saying we could approach this just like we would approach any algebra problem, even if there were whole numbers. Like let's say I had 6 equals negative 4u plus, I'll use minus, negative 4u minus 7 or something. So in that problem, the first thing that you would do is just add 7 to both sides. So in our analogy, the first thing that you did was add 9/5 to both sides, doing the addition before we worry about any multiplication or division. And now that gives us a fraction addition problem over on the left-hand side, negative 3/2 plus 9/5. So let's pause to do that arithmetic. What's the common denominator for that?
10.
Great. Multiply the negative 3 by 5, multiply the 9 by 2. We do that arithmetic and we end up with 3/10. So now on the left-hand side I have 3/10. On the right-hand side I have negative 2/7 times u. We've done all the addition and subtraction that's fit to be done, so where do you want to go next?
Then I divide the 3/10
By?
by the negative 2/7.
Exactly. Now that we've finished with all of our subtraction and addition, the next thing we worry about is division and multiplication, and sure enough, our u is being multiplied by negative 2/7. So if we want to get u by itself, let's divide by negative 2/7. And now we have a fraction division problem. 3/10 divided by negative 2/7. How do you divide two fractions?
The second one.
Flip, yes. Multiply, yes. Thank you. Great. So multiply by the reciprocal, which means flip the second fraction and trade division for multiplication. So we'll multiply 3/10 by 7 over negative 2. And when I multiply, I can multiply straight across. And lo and behold, there's that same fraction that we got the other way. So maybe the moral of this story is use whichever approach makes you the most comfortable. When we cleared denominators, we completely avoided having to do any fraction addition, and we completely avoided having to do any fraction subtraction. The only fraction operation that we did was we multiplied some fractions by whole numbers and reduced them to lowest terms. And that's the extent of what we had to do with fractions in the clearing denominators approach. In this approach, we economize a little bit by saving that step of clearing denominators, but instead, the trade-off is we had to do more different types of fraction arithmetic along the way. We had to add fractions, we had to divide fractions. And if you're comfortable with doing those two things, then by all means, choose this technique. If you would feel more comfortable getting rid of the fractions first, by giving yourself a problem where what you have to do is multiply by a whole number and reduce, then the technique of clearing denominators might be for you. But either one will work if followed carefully, and if you use the reverse order of operations, SADMEP, to unwrap that variable. SADMEP is kind of an end game when you're solving an equation. It's once the left and right-hand sides of the equation have been simplified, and, so I'm going to try to write this, once left-hand and right-hand sides are simplified, and the other thing that we might need to do, and we'll talk more about this on Wednesday, and the variable exists only on one side. So we're going to look at how to solve equations where the variable appears on both sides, but we would need to fix that first before using SADMEP. So as long as we have an equation where the variable is only on one side of the equation and everything has been totally simplified on the left and the right-hand side, SADMEP will do. But one of the things we'll see in the second half of our course is it's not universal. Not every equation will yield to SADMEP, even when it has been simplified and everything is on one side. But those equations we concern ourselves with in the first half of the semester will not have any exponents floating around. We won't see x to the power 2 or anything like that. We'll only see the variable to the power 1, and we'll only see constants. And for those types of equations, this is true. Once the left and right-hand sides are completely simple and the variable is only on one side, then SADMEP is your end game.